Sorry about that. I just left you hanging. Anyway, open circle equals, hey, control thyself, pen. Open circle, oh, that's why. Okay, get over here. Open circle equals, no, it's not equal to. In other words, you cannot land there. It's a limit. It means that you can approach it, but you can never, ever, ever land there. But you can get super close. You can get infinitely close. You can keep getting as close to there as you possibly could for all infinity, but you'll never be able to land on there. This one says x is greater than or equal to 8. And here's what they're trying to get. They're trying to get the kids who learned in middle school to color the side. Honestly, I don't know what middle school teachers teach, but sometimes they're like, color in the arrow the direction, color in the direction that the arrow is pointing. And that's a stupid way to do it. Why? Because the arrow could possibly, the x could be on the other side. You need to read it. And it says x is greater than, okay? It means x is bigger than 8. It's also bigger. So here's 8 on your graph. We're going to put a solid dot, and because there's an equal sign, so it's x is bigger than 8. It's also equal to 8. That's what I was going to say. Okay, and you color the arrow. All right, it'll be much nicer on Alex. Still getting used to my tablet here. Okay, write an inequality for the graph shown. Okay, so now we're going backwards. They're giving you a graph. Well, a solid dot means it's equal to, and this is greater than. Greater than is always going to be to the right. Okay, greater is to the right, and less than is to the left. You don't really need to remember stupid stuff like this, though, because you can just think it. Look, what's a number greater than 1, 2, 3, 4? All of these numbers are bigger than 1. So anyway, we would go x is greater than or equal to 1. Okay, if I had this right here, an open circle here, and it was colored this way. Wow, this is like so hard, y'all. No idea. Okay, that would be x is less than -4. Okay, we did open circle at -4 and then less than. All right, moving on. Next problem. Translate a sentence into a compound inequality. Compound inequality is the case where you have the variable and it's usually greater than something and less than something. So like there's going to be a number here. It might even be greater than or equal to something. And then there'll be some number here and there'll be some number here. So it's between there. Okay, so it says write the following as an inequality. 9 is greater than x. So write that right away. 9 is greater than x. And 3 is less than x. 3 is less than x. They're purposely giving this to you in a weird order so that you have to flip it around. Okay, see how 3 is less than 9? The lower number is going to go on the left-hand side, and you're going to write it in a logical form. So 3 is less than x is going to come down here, and then we're going to flip this around. X, because always read it from the point of view of the variable. Like that's you. This is like where you're standing. X is less than 9. So less than 9. You have to kind of flip it around. And I think they're going to do that just to see if you can do that. It's basically saying x is between, this is the way I always like to read it. X is between 3 and 9. Okay, moving on. Graphing a compound inequality on the number line. So now you need to graph that, okay? Hey, I'll try to use this number line here. Let's see if I can do it. Oh God, this is so hard, y'all. No idea. Okay, it says x is, read it again from the point of view of the variable. X is greater than, okay? Greater than 5 and x is less than 7. Okay, so here's 7, here's 5, here's 6. X is greater than 5, so it's going to be an open circle at 5, and it's going to be going this way. but also we want x to be less than 7. So we can't actually go past 7. We got to do an open circle at 7, and it's going to go that way. So x is between 5 and 7. Just read what it says. And if you want, sometimes you can even like name a number. X is greater than 5. Give me a number greater than 5, 6. And x is less than 7. Give me another number, less than 7, 6.5, 6. See? And it fits. Moving on. Okay, this is set builder and interval notation. Interval notation is kind of new to you all. And I think I did it third period yesterday accidentally with Taylor, but that's just because we jump in the gun here. This little line here in math reads as this, such that. It means that. So this says graph the set. Remember these little pretty brackets are sets. Graph the set x such that -4 is less than x is less than or equal to 3 on the number line. So look, all it's saying to you is just read this. It's just telling you that x is between -4 and 3. And there's an open circle at -4 because it's not equal to. And there's a solid dot at 3 because it is equal to. And then it's just going to be the part in between. Okay. All right. And then it says write using interval notation. All right. Interval notation. I don't remember if we've done this in this class because I get confused between here and algebra 2, but here's the way it goes. Parentheses means not equal to, and brackets means equal to. So for this case, the 4 is a parentheses because it's not going to reach -4. Comma, you put a comma between, and then 3 it is because it's a solid dot. So what this is saying is x is going from -4 to 3. Can't land on -4. It is greater than -4, but it is actually less than or equal to 3 because the bracket is there. That's the most important thing. Also, there is infinity. There's positive infinity when the arrow just keeps going in for, ever. And then there's negative infinity when it goes forever in the left direction. Infinity always takes parentheses, always parentheses. And in this case, that's a positive, so it would be on the other side of the interval notation. Positive wouldn't be on the left-hand side. That's silly. Okay, so it would be, sorry about that, here, and this would be like that, depending on how it goes. So for example, I guess I should just give you an example. If it went like this, let's say this is your graph, and this is 4. It would be, this is a solid dot, it would be bracket 4, comma, infinity. And if it went like open circle at 2 and to the left to infinity, that would be parentheses. We always read left to right. I know it seems like it starts at 2 and goes that way, but that's not really true. We walk left to right. So we're looking and we're going from negative infinity and we have to stop at 2, but we can't reach 2. So it's a parentheses. Okay. All right. Moving on. Last one. Union and intersection of finite sets. The danger zone in here is in Alex. For the intersection, they're going to want you to write your sets with an upside down U. And for the union, you need to write a U because U for union. That's how I remember it. U for union and then not U for the other one. Okay, intersection. Okay. So when we're looking for intersection, okay, and union, okay, so for me, union means add everything. Intersection means what do they have in common? But that is not what the letters mean to me. So I am actually going to look this up real quick. For some reason, I have a fear that I'm going to tell you wrong. Union. Here we go. I'm going to do this, and then I'm going to do images. Ready? Just very simply, it's going to tell me back here. A union B means name everything that's in all sets. Intersection means name what's in common. Okay? Here's a nice picture. Oh, here's a better picture. Check this one out. Look, intersect means this. You find what they have in common. Union means just name it all. Okay, and we're not doing the minus except. All right, we're going back. Back. So here, okay. So the union, I'll draw little pictures here really quick. This is good. Good little illustration. I'll even make little circles. Let's make them colored. Okay. Ooh, can we fill them? Ah, we could fill them, y'all. Okay, wait. Here. This is cool. So look, we got a little circle. We're gonna make a union and we're gonna make intersection. Okay. I don't know. Maybe we'll make this. Trying to make this too much fun here. Okay, let me do yellow. And let's see if I can do this. Okay. I don't like the way that came out. It needed to be a different color. What the heck, man? Delete that sucker. Here. I need another circle. Sorry, guys. Okay. I want a different color. Give me green. Give me green. Okay, here we go. Let's try this. Okay, whatever. It's going down. I can't do it. Screw it. Okay, I tried. I tried to make it fun. I duplicated it. Delete. Delete. Okay, so let's go union. Let's try not doing that. Let's go union. Union means you're going to list everything. Everything. It's all going to be there. Okay, so whatever's there, it's all there. Okay, all of it. It's all there. It's all everything in here, everything in here, everything in here. Okay, boy, that is so much uglier than theirs. So I can't help it, guys. Sorry. Get back up there. Okay, why is it doing that? Sorry. Here. Andale muchacho. What is this? I can't see this. Okay, there we go. Come on. Okay. All right. Intersection. Oh, I'm just rolling with this at this point. I'm so tired of fighting with this. Intersection means take what they have in common. That's what intersection means. Okay, so in this case, the union of these two sets, okay, is just list all the numbers. That's all. Okay, so you would go G, well, let me do it here. G union H equals the set, just name all the numbers, 0, 1, 2. We don't care that 2 happens both places in the sense that we don't have to list it twice, just once. And that's it. Okay, what in G intersect H is equal to, what do they have in common? The only thing they have in common is the 2 and the 6. So that's the intersection. Okay, and that's it.